Hello friends, in our previous video we have done three methods to find rational numbers between two given numbers. The first method was the mean method, average method. Second method was addition method, and the third one was formula method. Today we will do one more method, the LCM method, to find rational number between given rational numbers. We learn this method with the help of example. Let us take the question. We have to find out four new rational numbers between, say, 2 by 3 and 5 by 6. So in LCM method, first we will make the denominators of both the terms same. Here we take the LCM. The LCM of 3 and 6 will be 6. To make this 3 as 6, we multiply the numerator and denominator of this fraction with 2. It becomes 4 by 6. Second term is same, 5 by 6. Now we find four rational numbers between these new numbers, 4 by 6 and 5 by 6. Because we have to find four rational numbers, we take 4, increase it by 1, it is 5 now. We make these two numbers multiply both numerator and denominator with this 5. It is 4 5s are 20, 6 5s are 30. Similarly, 5 by 6 multiply numerator and denominator with this increased number 5, and we have 25 by 30. Now the numbers are 20 by 30 and 25 by 30. This is same as the terms in question. Now we write the numbers between 20 and 25. They are 21, 22, 23, 24. And denominator same, upon 30, like this. These are the four numbers we have found between these two numbers. And these rational numbers were 0 gets cancelled, 2 by 3, and here at the table of 5, 5 by 6. Means our question same. And we have found four new rational numbers between two given numbers. So these are the four methods to find out the rational number between given numbers. Now we proceed towards next topic, the decimal representation of a rational number. The decimal representation of rational numbers help us to distinguish between rational and irrational numbers. We are taking these three examples. Let us divide these all and make them the decimals. Then we will discuss their types. The first one is 5 by 8. Taking 8 outside and 5 inside the divide sign. 5 is not divisible by 8, so we make it 0 and put a decimal like this. So it is 8 6s are 48, 2 remainder, again 0, and we have 8 2s are 16, 4, 0, and 8 5s are 40. So the answer is 0.625. The second fraction is 2 by 6, and its decimal representation will be something like this. 0 and decimal we make it 20. 6 3s are 18. and 2 is left. Again make it 0. 6 3s are 18. Again 2 and 0 20. 6 3s are 18. Again 2 and so on. The answer is 0.333 and so on, or we can write it as 0.3 repeated. Repeated means bar. And in the third case, it is 7 here and 3 inside. 0. We put decimal. 0. 7 4s are 28. 2 is left. 0. 7 2s are 14. 6 is left. 0. Then 7 8s are 56. 4 is left. Again 0. 7 5s are 35. 5 is left. 0. 7 7s are 49. 10. 7 1s are 7. 3 0. 7 4s are 28. 2 0. Then 7 2s are 14. 6 0. 7 8s are 56. 4 and so on, and it is from here repeated 20 20, 60 60, 40 and so on. Means here the answer is 0.428571. Again 4285 means repeated like this. Now we have done the division 3 times and all the 3 answers are of different kind. Here the answer is complete, remainder is 0. No remainder is left. This kind of division is called terminating. It has ended. Terminating decimal representation of rational numbers. In this division, the answer is repeating and the same number is repeating. It is non-terminating. Non-terminating. Similarly, this is also non-terminating. But here, in both the cases, the terms are repeated. Whether it is the same number or the digits, after some time they are repeating. So these are called non-terminating, reoccurring. Non-terminating, recurring decimals, these are called. So a rational number when divided can give us terminating decimals or non-terminating recurring decimals where only one digit can be repeating or digits can be repeating after a certain period. This is the decimal representation of a rational number. Then what about the irrational numbers? Let us see. 5 by 8 has the decimal representation 0.625. 2 by 6 has got non-terminating, recurring. 3 by 7 has got the value of 0. Repeated 428571. Now here are two numbers, under root 2 and pi. The value of under root 2 is something like this and pi has got the value like this. The repetition of digits is not possible here. When we did the division or the decimal representation of these two numbers, the digits are not repeated, not recurring. It means we are not getting something periodic, something repeated. So these two numbers are irrational numbers. They are not rational when they are non-terminating and non-recurring. They are not occurring again and again like here or here. So these are the rational numbers, and this type of numbers are irrational numbers. So friends, today we learned the methods to find rational numbers between given numbers and the decimal representation of rational numbers. In our next video, we will do the representation of a rational number on number line. Till then, you practice these sums properly, and for any queries, write to us in our comment box. Subscribe our channel for more videos and press the bell button also. Now we take your leave. Take care and work hard. Bye bye.